Hey guys, so till now we know what a differential equation is, and the different kind of ways in which we can create a differential equation. What kind of curves give you what kind of differential equations, right? Satisfy what kind of differential equations. Now we will formally talk about the method of solving first order, first degree differential equation. First order means the highest derivative involved in the differential equation will be dy by dx. First degree, that is the power of dy by dx, will be 1. So first order, first degree equations. So dy by dx is equal to some function of x and y. Now, if fxy, if this dy by dx or fxy can be expressed as a product of some particular function of x into some particular function of y, gx into hy, then the differential equation is called variable separable type. Variable separable type, you might have heard this word. So what does it basically mean? So you have a differential equation dy by dx equal to fxy, function of xy, and you're able to decompose it. You're able to write it down as just gx, that is some expression in terms of x multiplied by some expression just in terms of y. Then you can call it variable separable type. So this is what is a variable separable type differential equation. So dy by dx is equal to gx into hy. If hy is not equal to 0, then that means what I can actually do is I can put the x things together and the y things together. So what I can do here is that I can take h down here and I can take dx up here, so that I have x things together and y things together. So when I say x things, y things, what do we have here? We have dy, and in the denominator you will have h, the function of y, and equal to gx into dx. Now, if you integrate on both the sides, then what will you get? If you will integrate on both the sides, so on left hand side you are integrating dy, so with respect to y, and on the right hand side you're integrating with respect to x, we will get a solution in the form, of course, from the left hand side you will have something in terms of y, and on the right hand side you will have something in terms of x. So you will get an expression like this. You will get an expression like hy, some expression in y equal to some expression in x, gx I'm calling it, plus some constant c, because when you integrate you do get this constant value, right? So this is what is the method of variable separable type. Okay, so variable separable, very easy. You can separate the x and y terms and integrate with respect to y and x on both the sides, and you basically get the solution. You are able to solve basically. So for example, let's work on some examples here. So if you have dy by dx equals to x plus 1 upon 2 minus y should not be equal to 2, of course. Y should not be equal to 2. That's the domain restriction that you have here. Now clearly I have some term which is just in x. This is just in x, and this part is just in y. So I don't really need to do anything. I clearly can see that you have something just in x and just in y as a product. So I can take the y terms with y and x term with x. So 2 minus y dy will be equal to x plus 1 dx. And now I'll integrate on both the sides as required. So integrating on both the sides, very easy to integrate on both the sides. 2 minus y dy, when you will integrate, you will get 2y minus y squared by 2, and x plus 1, x squared by 2 plus x. And of course, you have a constant c also. So I'm taking, we generally take it on this side. So we'll take it here. Now take the LCM, get everything together. Take the LCM and get everything together. This becomes your general solution of the differential equation that you have. So the differential equation that we have must be getting solved by this kind of a curve. That's what it basically means. This kind of a curve is solving that kind of a differential equation. That's what it means. It's a general solution to that kind of a differential equation. Let's take another example. So dy by dx is equal to 1 plus y, 1 plus y square upon 1 plus x square, where 1 plus y square is not equal to 0. Of course, it is not equal to 0. So that means I can take it in the denominator. So is 1 plus x square. 1 plus x square is also not equal to 0. So I can have it in the denominator. So again, you can see that you have just the y term and just the x term. So how will we deal with it? We will take the y terms with y and, we will take the y term with y and the x term with x. So we will get dy upon 1 plus y square and dx upon 1 plus x square on the other side, and you have to integrate. Here you integrate with respect to y, here you integrate with respect to x. Now, do you remember what is the integration for 1 upon 1 plus y square? So basically, if you remember, the derivative of tan inverse x. The derivative of tan inverse x is 1 upon 1 plus x square. So hence the integral of 1 upon x square is tan inverse x. So 1 upon y square, that means it's tan inverse y, and 1 upon x square on the other side, that is tan inverse x. So tan inverse y equals to tan inverse x plus a constant c. For integrals, you do get a constant. That's the general form. And this is the general solution to your differential equation. So the differential equation that we have is definitely being solved by this kind of curve. dy by dx is equal to minus 4 times x into y square. Given that y equals to 1 when x equals to 0 and x equals to 0, which basically means that I want you to find out the particular solution also for this x and y. So find the general solution and then put in the value and find the particular solution. So I would like you to do that. And again, what you can see here is that you have the x term and the y term in product. So I can actually separate. I can get this here and get this here. So y terms separated from the x terms. So it's going to be integral of dy upon y square equals to minus 4 times integral of x dx, right? So integrating on both the sides with respect to the respective variables. So integrating with respect to y, here you will get y. You have y to the power minus 2, so plus 1 in the denominator as well. So you have y to the power minus 1 upon minus 1. That means it's basically minus 1 upon y. And here you will have x squared upon 2 with minus 4 along. So this cancels with 2 here. And basically when you will take it to the other side, or when you will just rewrite it, you are getting minus 1 upon y equals to minus 2x squared plus c. Or in other words, you are basically getting y is equal to 1 upon 2x squared minus c. And what we can do is, now in particular solution, we do not want any arbitrary term. So we'll have to get rid of the arbitrary term. So just put x and y value and get c and then substitute. So y equals to 1, x equals to 0. That means c would be equal to minus 1. So c is minus 1. The moment you will put the value of c as minus 1. So y becomes the curve. The curve becomes y equals to 1 upon 2x squared plus 1. 1 upon 2x squared plus 1. This is a particular solution. This is what we mean by particular solution. Okay. So when you get rid of the arbitrary terms, that's your particular solution. Find the equation of the curve passing through 1, 1, whose differential equation is x dy equals to 2x squared plus 1 dx, where x is not equal to 0. Okay, so if this is the differential equation, so what we can do is we can just try to separate terms here. I can see that I don't have any y term except for dy. So dy I'll keep on one side and I'll take all the x terms on the other side. So I have 2x squared plus 1 upon x, which basically gives me 2x plus 1 by x. So I'm going to integrate on both the sides. Integrating on both the sides clearly will just give me y here, and here I'll get 2x squared by 2 plus log of mod x plus c. Okay, so this is what we get here. So we get y is equal to x squared plus log x plus c. And this becomes the curve. This is the curve which will satisfy the given differential equation. Okay, so this is the curve which will, the family of curves satisfying the differential equation looks like this. Now, we have a particular case also. We need that it should be passing through 1, 1. Passing through 1, 1 means that x and y both are 1, right? So at the same time, which gives me that the value of c, if I put x and y as 1, 1, then the value of c, since log 1 is 0, value of c is 0. So which means the particular solution, what we figured out up till now was a general solution. And the particular solution will be where c is essentially 0. This becomes x plus log x, y equals to x plus log mod x. That is the particular solution. Find the equation of a curve passing through minus 2, 3. Given slope of the tangent to the curve is 2x upon y squared. Slope of the tangent is 2x upon y squared, means that dy by dx is 2x upon y squared at any particular point x. That's what it said. So therefore, dy by dx is equal to 2x upon y squared. Clearly, I have segregated function in terms of x and y. So I can clearly separate. So this is a variable separable case again. So you can clearly, put the dx, put the x terms together and the y terms together. And what we shall be getting is we'll integrate y squared dy and we'll integrate 2x dx. So we get y cube upon 3 is equal to x squared plus c, which means that now you can take 3 on that side also. You can probably write down that, y cube is equal to 3x squared plus 3c. Whichever way you do it, we need a particular solution as well. And the particular solution is, we need that it is passing through minus 2, 3. So x is minus 2 and y is 3, right? So just put in the value x minus 2 and y 3 and you will be getting the value for c. C turns out to be 9 minus 4, that is 5. So c is 5. All you need to do is just put in the value in the general solution that we had. Just put in the value y cube upon 3 equals to x squared plus 5. So y cube equals to 3x squared plus 15. Y is equal to cube root of 3x squared plus 15. A different kind of a question in here. In a bank, principal increases continuously at the rate of 5% per annum. In how many years rupees 1,000 double itself? That is, in how many years will you be able to make 1,000, 2,000? Okay, with a continuous rate of increase in principal of 5% per annum. So essentially, if P is your principal at particular time t, okay, whatever is their time t, initial time, P is the principal, then according to the question, we know that the rate of change, dp upon dt, if t is the time, right? So dp upon dt is 5% of P. So 5% of whatever amount is there, right? So 5%, that's the rate. The rate of change will be 5%, that is 5 upon 100 into P. Okay, so this is what we have. So we have that dP upon dt is 1 upon 20 times P. So if I just take the P value, P term together, so it'll be like P out here and T with 1 by 20. So I have dP upon P is equal to dt upon 20. Integrate on both the sides. Integrate on both the sides. So you'll have log P is equal to T by 20 plus C. There's a constant C, right? Log, you can get rid of log by taking E. Entire log is basically exponential. So you take the exponential and you will get P is nothing but e to the power T by 20 plus C. Now, when you have exponential term and you're adding in the power, so if you have A plus B, so this you know that base is same and you have power A and B, then you can just add, right? So e to the power T by 20 into e to the power C. So we can just, probably take e to the power C is also some constant C. So we've taken that as C. So P essentially is some constant C into e to the power T by 20. So whatever T would be, that would be the case. Now, we want to know that what would be T for this P to be 2000. So how we can figure it out, I'll just tell you how we can figure it out, but we can actually find out this constant C, because what we know is that initially my P is 1000. So initially means T is 0. Initially T is 0 and my amount that I have, principal amount, is 1000. So C becomes 1000. Because P is equal to C e to the power T by 20. E to the power 0 gives you 1. So C is 1000. So putting C as 1000, that means I get that P is equal to 1000 times e to the power T by 20. Now I need to know when can this P be 2000. So this P can be 2000. This P can be 2. P is 2000. T should be, put P equals to 2000. So 1000, 2000, you will get 2 here. So e to the power T by 20 is equal to 2. E to the power T by 20 is equal to 2. So which means that if you take log on both the sides, you will get that 20, you will get that T upon 20 equals to log 2. 20 can go there. So 20 log 2 is equal to T. So 20 times log 2 is equal to T. For doubling the amount from 1000 to 2000, what is the value of T? How much time will you take? 20 times log 2.